We observe and apply physics every day, but now we will focus on torque and its different applications in our daily lives. So, what is torque? Torque is also known as the moment of force. Torque is defined mathematically as T is equal to R multiplied by F, or R multiplied by F sine phi, in which T is represented by and R is the moment arm with the unit of M. In other words, torque is the cross product between the distance vector, the distance from the pivot point to the point where force is applied, and the force vector A being the angle between R and F. Torque is a vector quantity, thus direction must be specified. The counter direction is the positive, while the clockwise is the negative. Now let's take a look on how torque is applied on the doors of Makura. So when pushing a door just like this, your force or your push will cause the door to rotate about its hinges or its pivot point. So when you push a door near to its pivot point, it is hard to push, so that door won't open easily. But if you go far from its pivot point, you can push the door easily.
Another activity that torque is applied in our daily lives is carrying the bags on our arms. The elbow acts as a pivot point and the moment radius is from pivot point to the fingertips. And the force applied in the torque is located at the hand. And the angle, which is sine theta, is between the radius and force applied.
Good day everyone, today we're going to discuss about torque. So, what is torque? Torque is the measure of the forces acting on the object that causes it to rotate. There are three factors that affect torque. First is the moment arm, which is located at the pivot point for the force that is applied, which is like, if this is the pivot point, then this is the force applied. And that is the moment arm, which is represented by R. And second is the force, which is represented by F. And the theta, that is represented by theta, which is the angle. For example number 1, let's assume this is the 0.72 meter door, and let's assume this is the hinge of the door. There's a force acting in the door which has a 5 newtons. There's a 57 degree angle from here to here. So to calculate the torque of this door, let's first find the radius hinge to the force acted on an object. So here is the moment arm, which is the R, which is 0.72 meters, and the force is 5 newtons that is given in the problem. And the theta is from the moment arm to the force, which is this. So we can calculate it by, they can subtract 180 degrees from 57 degrees to get this angle. So the angle is 150 degrees. So we can calculate for the torque. The equation is 0.72 times 5 sine 123 degrees. And the answer is 3.019 meters. So for example 1, we have given a door with a 0.72 meter door. So let's assume this is the hinge of the door and it's acted with a 5 Newton force here with a 55 degree angle. So how to get the torque? Let's use the equation of the torque, which is T equals to moment arm times the force that's applied on the object. Sine theta is the angle from the radical arm through the force acted on the object. So here is our theta, equal with 180 minus 55 degrees, which is 125 degrees. R is 0.72 meters. The force is given with 5 newtons. Sine theta, which is 125 degrees. So the torque that's acted on the door is 3
0.09 Newton meter. So here's another example of torque.
So, there are two forces that's acting on the object. First is at the half of the door, and second is at the tip of the door. They have both 12 Newton forces acting on the half end. They have 55-degree angle from here to here and 55-degree angle from here to here. So, to calculate for the net torque of the object is we need to calculate the both torques of this torque. So for this side, we have R of 0.84, that is half of the 1.68 meter, since it is started from the half of the torque. So the force is 12 newtons with an angle of 55 degrees because it started from here to here. So we will get the 55-degree angle. So the second has also a 12 Newton force, but the R is 1.68 meter because the force applied is located at the tip of the door, which is 1.68 meter in the hole. So the R is 1.68 meter. The angle of it is 180 minus 55 degrees since the angle from here to here is 180 minus 55 or 125 degrees. So if we calculate the net torque of it, so we need first to calculate the torque of this and this. The torque of this side is 8.25 Newton meter and the torque of this side is 16.5 Newton meter because this is below the moment arm. The sign of the torque is negative. When the force is applied above the moment arm, the sign of the torque is positive. But if the force applied is same as the moment arm, it is zero. There are no positive nor negative signs. So since this is below the moment arm, the sign is negative. So if we add these two, we will get negative 8.25 Newton meter because this is 8.25 Newton meter and this is negative 16.5 Newton meter. If we will get the summation of the torques, we will get negative 8.25 Newton.
For example 2, we are given a 1.68 meter door. 1.68 meter door. So let's assume this is the hinge of the door. The door is acted by two forces that is located at the middle of the door, which has a 12 newtons. Let's call this F1 with an angle of 55 degrees. And the second force is located at the tip of the door, which also have 12 newtons. Let's call this F2, which also have 55 degrees angle from here. So the theta of this force 1 has 55 degrees. It's theta 1. The theta 2 of the force 2 is here. Theta 2. Percent is 180 minus 55. Theta represents the angle from the radical, the radius moment or called moment arm. So this is the moment arm from here to the force. So we need to calculate this angle. So this is the theta 2. So it is 125 degrees. This is the theta 2. So for this kind of situation, we have two torques that's acting on one object. We need to calculate the torques of this per object. So torque 1, torque 2. But first, let me say the rules from the torques. The sign rules. If the torque is above the moment arm, it means the torque is positive. When the force is above the moment arm, the torque is positive. Well, if the force is below the moment arm, the torque is negative. So this torque has a negative torque and this torque has a positive. So let's now calculate for the torque of this object. This will be calculated by the summation of all torques that's acting on this object. So the summation of all torques is torque 1 plus torque 2. So let's calculate for torque 1. Has an R of 0.84 because the force that's acting on the object is located at the center of the door, which is the R. The whole door will be half, so the R will be calculated for the torque 1. And the force of the T1 or the torque 1 is 12 newtons with sine theta, which theta 1 is 55 degrees, sine 55 degrees. So torque 1 will be equal to 8.25 Newton meter. For torque 2, so let's label it torque 1. For torque 2, this is torque 2 is equals, the R of torque 2 is 1.68 meter because from hinge to the tip of the door is 1.68 meters. So the R of torque 2 is 1.68 meters with a force of 12 newtons, the same as torque 1. 12 newtons, which has sine theta 2, which is 125 as we calculated earlier here. So we can calculate this. So since this force is below the moment arm, the torque is negative. So if we calculate this, we have a negative 16.5 Newton meter. So to calculate the summation of torque is we should just 8.25, this is the summation of torques, 8.25 plus negative 16.5 Newton meter is both Newton meter. So the answer is negative 8.25 Newton. This is the final answer. Torque that is acted on this door is negative 8.25 Newton meter.
Okay, so hello everyone. I'm Jerry Serial. I'm the man behind the camera and all the editing. If you enjoyed this video, I would like to encourage you to subscribe our channel and watch this video right here. It's all about corporate entrepreneurship with our very own friend, Ezra. Enjoy it.